I think the time is now 2 minutes past 11. We've only got an hour scheduled, so I think we're going to kick off. There might be some more folks joining, but that's okay. We are recording this webinar, and we will make it available for you to view again, reference again. So great, pleased to have you with us. This is our, it's been a while since we've done a webinar, and this is our first webinar on the Databricks platform, and we plan to have a number of these, and today's will be a broad overview of the Databricks platform, and then we'll have follow-up sessions that go into depth on the various capabilities that Databricks provides. Great to have you here. And Claudia, I think if you could maybe swap to some of the slides that we have, and then we can kick off. Excellent. So thank you again. And my name is Lionel Bischoff. I founded Learning Machines in about 2016 after doing software engineering and agile training, sold a company to TOH and left them in 2015, and then started Learning Machines. There's about 15 of us now, and we are really loving this journey. It's tough, I must say. Some of these projects are the toughest projects that I've ever been part of in the technology landscape because of it combining software engineering, data warehousing, machine learning, all kinds of sort of new approaches and integrations, really complex projects. So great to have you with us. With me on the call is Claudio Jardim. Claudio is a certified Databricks solutions architect, great experience in machine learning as well as data engineering. And Claudio will explain to you in quite a bit more depth an overview of the Databricks platform. Just to tell you a bit more about Learning Machines. This is the agenda, so we'll just tell you a little bit more about Learning Machines, and then there'll be a webinar and questions for about 10 minutes afterwards. But also use the chat to ask questions, and we have folks monitoring the chat, and we can answer questions in the chat as well. So great, in terms of Learning Machines, 3 big focus areas: big data. Now that data is not only for humans, it's also for the machines. It's ever greater focus on being able to gather the right data and make it available in your organization. And the point of getting the data is so that we can train the machines. In one of our training courses that we do, Fred uses a slide of Morpheus from the Matrix. And Morpheus says the job of the humans is to prepare the data for the machines. And what I have often said also is that if you have 1 propeller head, you most likely need 10 data engineers. I think that will reduce now for folks that are using platforms such as Databricks. They make it a lot simpler. But if you're doing this on-prem, definitely I think the ratio of 1 propeller head and 10 data engineers is a correct one. So that's the one area of our focus is getting the data and preparing it for humans and the machines. And then machine learning is to make use of this with the latest technologies across, whether it be vision-based, NLP-based, typical credit scoring solutions, anything like that. We have a broad range of experience and highly qualified folks in these fields that can assist you in using these machine learning solutions. And then, of course, the journey to the cloud, which I imagine most of you are either well advanced in or starting off, but everyone is moving in this direction. So we focus on all those 3 of those areas, combining software engineers with software architects, machine learning, big data engineers. And you really need all those people if you're going to do all this in a large scale across your organization. So some of the projects we work for the largest financial institutions in South Africa, some of the largest banks, and we do things like, well, for one of our customers, we build 60 billion features on a weekly basis, and we also do that for streaming as well. So the feature sets that is used by a couple of hundred of their data scientists across their organization, We put the infrastructure in place and the featured jobs on both an Apache and a streaming basis to do that. Another of our customers, we run their Hortonworks cluster. We assist customers in Kafka infrastructure, event-based processing, building rules engines for marketing, pressure management, everything basically that you need to do to turn your organization into an automated intelligent agent. Capturing events, enriching those events with features, taking decisions on those events and the enriched information based upon machine learning models, and being able to take action. And that means integrating into your apps, into your various channels that you have. And we have the skills and have done this before for various organizations. And then we also facilitate workshops where you send your software architects, your data architects, and we have a 2-day workshop with them where we take them through the latest, greatest in the tools and techniques in both big data on-prem and in cloud, as well as machine learning and MLOps. So quite a broad range of experience that we have, and there's about 15 of us in the company. Great, Claudia, if you could progress to the next slide, please. I don't see it coming up for some reason.
It is up. Oh, I don't know.
Maybe it's just on my side that I'm not seeing it. Apologies. Just click again. I'm not seeing anything. There we go. Okay, just it's got some animation, so I think you'll need to click a couple of times. Sorry, man. So if we look at the landscape in which all this is occurring, we all have our systems of record, the systems that have been running for many years, whether it be ERP or SAP or a mainframe system. Those systems are very mature. Next one. And then systems of engagement. This has been the digitization journey of the past 10 years. Many companies are, and most actually, are quite mature in this space now. We have websites and we have apps, IVR, chatbots, many digital ways for customers to engage with our organizations. Now that we've got all this digital data, we can use this to build systems of insight so that we can take better decisions. And as we take better decisions, we can build systems of automation, which will enable your organization to become ever more an automated intelligent agent. This is tricky though. This is a very fast changing space. The competitive landscape for the future is for the now and the foreseeable future is systems of insight and systems of automation. Rapid, fast changing. If you try to do this on premises, we do this. I mean, it's tough, really tough to do this. And that is why we highly recommend that organizations move as quickly as possible where their innovation in terms of systems of insight and systems of automation occurs in the cloud. And that is what Databricks is. It is a fully integrated solution enabling you to build systems of insight and automation for your organizations in the cloud, where everything is pre-integrated, works well together. And we are a Learning Machines is a Databricks partner, one of the very few in Africa. And we have a broad range of experience on all of the Databricks components, and we've been working on Spark on a big way since about 2016. And we look forward to assisting you in moving to low-cost, cloud-based data and machine learning infrastructure so that you can prepare the data for both humans as well as machines, whether it's fact and dimension tables and BI for humans, or it is data for the machine so that you can automate your organization. You can use Databricks platform in conjunction with Learning Machines, which can assist you in making the most of these solutions, whether it be data or machine learning based challenges. And we look forward to assisting you, and we look forward to hearing from Claudio more detail on the Databricks platform and what it can provide you. Thank you.
Thank you, Lionel. Just a bit of a background on Databricks. Databricks is a unified data analytics platform. So you can do all of your data science, data engineering, and business analytics all in one place. They currently have around 6,000 customers and several partners. We're one of the partners, as Lionel mentioned. And a lot of their customers are Fortune 500 companies. And Databricks is actually brought to you by the original creators of Apache Spark. As of recently, they've raised $1 billion in funding, and it's interesting to note that the major cloud providers were part of this. So that's AWS, Microsoft Azure, and Google Cloud Platform. Sorry. So if we look at the modern data architecture, it's quite a mess. So you have multiple data systems, lots of data movements, and inconsistent copies of data. There's lots of open source technologies which should be good, but these are hard to operationalize and secure. So you can basically filter these problems into 4 domains, which is the problems that the data platform teams face, which is messy, siloed, and slow data. Then your data science and ML teams, I mean, ML is already hard as it is, but operationalizing it is even harder. And then for your analytics teams, so they just aren't harnessing all of your data. A lot of your data goes to waste. And then of course, for your DevOps and security engineers, there really isn't enterprise readiness. So your security, reliability, and automation are all missing. So how does Databricks solve this? Well, for the first issue for the data platform teams, it's that given the variety and volume of data coming into your enterprise, the data should really land in a data lake. And Delta Lake is the solution. So Delta Lake is open format, open source, and open APIs. It runs on top of your existing data lake, and it makes your data reliable and fast. So you only have to build this once, and then you can access it many times for many use cases, including BI and machine learning. Then for your machine learning engineers and data scientists, so we all know that ML is an iterative process. You've got to optimize by changing your data, your algorithm, and your parameters. You also need to monitor this full life cycle. So from development to production, you've got to track drift and constantly fine-tune your model. Delta Lake provides access to reliable data and data versioning so that you can reproduce your models. And ML runtime packages up all the most popular ML frameworks so that you don't have to worry about versions and dependencies. MLFlow also standardizes the full machine learning lifecycle from tracking experiments to model deployment in production. Then for your analytics teams, so as we said, most of your BI is restricted to a small piece of your data that's sitting in something like a data warehouse. But by making your data reliable and fast with Delta Lake, analytics teams can access all of the data for reporting, analysis, and dashboarding. Then for your enterprise readiness, it's really all about connecting your data to your customers and doing this securely. So the way that Databricks does this is that your data remains in your own accounts. They just extend your existing data security protocols within Databricks. They provide you with cloud native security with tight integrations with AWS and Azure. So you can bring your own keys, bring your own network to easily integrate with your existing environment. We also make it very easy to onboard users with your identity provider while also providing visibility and controls to usage, budgets, and costs. So if you'd like Databricks, you should contact us and let us help you on the journey to your organization as an automated intelligent agent. We will now begin the webinar, which is going to demonstrate the full data analytics lifecycle and show you how Databricks can solve the current challenges that are faced. Okay. So I'm just going to ask that everyone keep their questions to the end of this webinar. If you have a question, you can type it in the chat, but I ask that you keep all your mics off and your cameras off, please. I'm just going to stop my video also. Okay. So when you log into Databricks, this is your home page. And in the top left, you've got this nice menu with everything you need, and you can choose your role. So the role that you required, there's data science and engineering, and then machine learning. Once you've chosen your role, you can then create a cluster. So we need a cluster to do things, and we just click on the compute tab, click on create cluster. You can give your cluster a name, choose the cluster mode, high concurrency or standard or single node, maybe for a job. And then of course you can choose your runtime. So there's standard runtimes and there's ML runtimes, which will be for machine learning. Once you've done all of that, you also have some autopilot options, which can enable auto scaling as well as termination. So if you forget about a cluster and you've enabled this feature, it will terminate after a certain amount of time of inactivity. You can then choose your worker type, specify the minimum and maximum amount of workers, as well as your driver type. For advanced users, there's also some advanced options that we won't go into. Back to the menu on the side here, you also have a data tab, which provides you a view of your database tables and your database file systems. So all of your data that's available will be here. And once you've got a view of your data, you can, of course, go into your workspace, which is where all your users will be, as well as your shared folders. And this is where really all of your ML experiments, your notebooks will be stored. So we've already got our notebook open over here. So if I click in here, this is a Databricks notebook. So Databricks notebooks allow collaboration. So you have a little comments tab over here that allows multiple users to work in the same notebook and communicate with each other. And your notebook can be set for a specific language. So we've set ours for Python, but you can enable it for Python, Scala, SQL, and R. You also have the option to customize permissions for all of your users. And within your notebook, you can schedule jobs using the schedule tab, or on the menu using the jobs tab. Then you have a handy feature, which is revision history, which allows you to sync to Git and version control all of your work, as well as a repos tab over here, which allows sharing and reproducibility of your projects. I already showed you the data tab, and over here is the experiments tab, which we'll use a little bit later, which will basically log all of your model runs. Over here is a feature store tab, which contains all of your feature tables and available features. And then your models tab, which is a record of all your registered models. So it's quite a lot, but I think the point is that Databricks really does have everything. So if we go on to the demo, we'll just have a bit of a background on the problem. So we are using a data set that represents thousands of loans made through the Lending Club platform. And our goal is to then use some of these variables and predict whether or not a loan is good or bad. So starting off with the data, we're going to use Delta Lake. So what is Delta Lake? So Delta Lake is an open source storage layer that brings reliability to data lakes. It also provides ACID transactions, scalable metadata handling, and unifies streaming and batch processes. As we mentioned, this will run on top of your existing data lake and is compatible with all of Apache Spark's APIs. There is although Delta Lake is open format, Databricks also has their own format called Delta, and it consists of 3 components, which is version Parquet files, a transaction log, and an optional table registered to the metastore. So why would you use Delta Lake? Well, firstly, it's open format, open source, and open APIs. It runs on top of your already existing data lake, making it reliable and fast. It has schema enforcement, and it's able to handle both batch and stream jobs, doing all of this with efficient operations and optimized partitioning. So in terms of business value, this really unifies your data. So instead of it being siloed, it's all in the same place. It's able to handle data for BI and for ML. Your data is also reliable and fast. And of course, it's infinitely scalable. So going on to our example, we just begin with a bit of data prep, and we use this ordering of our data, which is a suggestion by Databricks, but of course you can use anything you'd like. And it basically orders data in bronze, silver, and gold. And the data gets cleaner as it goes through these processes until it's ready for production. So we start off with our raw data, route it through to the different levels. Okay. We can see here's a view of our target. There's a bit of class imbalance there. And then finally, we go into our Delta table history. So just like your notebooks have a revision history, you also have a Delta table history for all of your tables. And this gives you a view of what was done under previous versions, who did it, what the operation was. And it also allows you to go back to previous versions. So for our EDA, we're going to use version 0. So we're actually going to time travel back in time and get an older version of our Delta table. And for EDA, well, we first have to know what is EDA. Exploratory data analysis refers to the critical process of performing initial investigations on data and checking assumptions with the help of summary statistics and graphical representations. So although EDA is quite simple, it is often very important because it allows you to easily discover patterns and spot anomalies. In terms of business use cases, this really does allow you to understand your data better. And a big help is that it allows you to identify problems with the data before you've begun your long modeling process. And furthermore, it also identifies interesting relationships between variables. So we are going to use the Databricks display command, which is unique to Databricks. And here we have a view of our data frame. Over here, we use one of the display commands plot options. And you can see here, we've gotten rid of that class imbalance. We then view some summary statistics, so the mean of all of our variables. QQ plot to check the distribution of our data, of the loan amount. And then finally, a really interesting graph, which is a world map graph that is also built into Databricks. Okay, so now we've got our data here, we've had a view of it, and we're now going to go onto the feature store. So what is our feature store? Well, the feature store is a central vault for storing documented, curated, and access controlled features. It really provides the link between the data engineers who create and write the features and the data scientists who read from the feature store and use those features. So why would you need this? Well, feature stores really separate feature engineering and model development. So you're making feature engineering a first-class construct. You are also able to compute and write your own custom features, and you can train models using these features whilst logging these models to your feature store. In terms of business use cases, all of your models can use, reuse, or use the same features as well as different features. Your data scientists can query a catalog of all of your available features, and your data sets are managed and governed. Going back to our example, we compute some custom features And we then create 2 featured tables whilst moving all of our data to these featured tables. So if I go to the Feature Store UI, which I've got open over here, you have a view of all of your feature tables, who created them, where their data source is, if there's any jobs using these. You're also able to search by feature table, feature, or data source. If we just go to page 2, you can see these are the 2 feature tables we created for our example. And if we click on a specific feature table, you have even more information on your feature table. And you also have all of your features here with some information on them, which models are using this. So all of your models can be logged to your feature store and which notebook is using these features. Going back to our notebook. So once we have our feature tables created, we can actually create a training set using our feature tables. So we're going to use both feature tables to create a training set. And once we have this training set, we're going to begin our modeling process. And we're going to be using MLFlow for this. So MLFlow is a platform to streamline machine learning development, which includes tracking experiments, packaging code into reproducible runs, and sharing and deploying models. So MLFlow actually offers a set of lightweight APIs that can be used with any existing machine learning application or library, such as TensorFlow, PyTorch, XGBoost, and a whole lot of others. And the question is, why should you use MLFlow? Well, to be honest with you, there's really nothing else like this on the market. And MLFlow has MLFlow tracking, which is an API to log your parameters, code, results in machine learning experiments. And you also have the option to compare all of these runs using an interactive UI. Your MLFlow Projects, which is a packaging format for reproducible runs using Conda and Docker. So it's really easy for you to share your ML code with others. And then your MLFlow models, which is a model packaging format, as well as tools that allow you to easily deploy the same model from any of the ML libraries. And this can be done to batch and real-time scoring on platforms such as Docker, Apache Spark, Azure ML, and AWS SageMaker. And then finally, you have your MLFlow model registry. And this is your centralized model store with a set of APIs and UI to collaboratively manage the full lifecycle of all of your models. In terms of business use cases, this is really amazing because you have all of your experiments logged to the same place with all of the information that you require. You're able to monitor the full lifecycle of your models, and you're able to track drift and constantly fine-tune once they're in production. This, together with Delta Lake, provides access to reliable data and data versioning, so it's easy for you to reproduce all of your models. ML runtime packages up all the popular ML frameworks, so you don't have to worry about versions and library dependencies, and your full ML lifecycle is standardized. And I think the best thing about this is actually the deployments. So you can literally deploy a model at the click of a button, and you have options for model staging and other deployment options. So for our example, we just put a logistic regression model and we logged that to MLFlow. We also created a few custom plots that we're going to stamp to MLFlow. Whilst doing this, we also stamp our model to the feature store. And then for a bit of a view of the UI, we created a random forest model with several different parameters so that we can show you how to compare model runs. So if I go to my experiments tab, you'll see I've got all of these different model runs. I can just click over here. This will open the experiment folder for this notebook. If I click on our logistic regression model, you can see here, so it's got your metrics and everything like that. It's also got an artifacts folder over here where we stored our custom plots. This model package file will have some information on the feature store, and you have your model file as well as an environment file that's all done for you. So if we click on the logistic regression model, MLFlow also creates a code snippet to predict on a Spark data frame or a Pandas data frame. And once you're happy with your experiments, you can register your model. So we've already registered it here. And if I click on that, you'll have a view of your model registry. You'll see your model name here, which is logreg, the version 1, as well as some other information on your model. You also have the option of transitioning your model. So if you don't have these permissions, you have to request a transition. But if you do, you can transition to staging, production, or you can archive your model. And if we go back to our experiments, I mentioned that we did another random forest model. So if I just click on a few of these runs, I can then click on compare at the top here. And then you have a really handy tabular view of all of your model runs, which are identified by their run ID, as well as their parameters and metrics. So you can find the best parameters that give you the best metrics. You can also compare these runs with plots, or particularly useful is the parallel coordinates plots, where you can sort of filter your model by a certain metric. Okay, so going back to our notebook, this is all the code that did all of that. And here's those graphs we created. We then move on to AutoML. So Databricks AutoML allows you to quickly generate baseline models and notebooks. Even if you're an experienced user, this can accelerate your workflow and fast forward through all the trial and error based modeling and allow you to really focus and bring your domain expertise to a specific model. If you're a citizen data scientist, this also allows you to do machine learning, and it does this with a low code approach. So it's sort of a glass box approach to AutoML, because although everything is hidden away from you, you also have the option of seeing it all. So why would you use AutoML? Well, it really does democratize machine learning by allowing everyone to use it. It will automatically set up your machine learning project, and it will generate all the code and notebooks for you. In terms of business use cases, this can really speed up your machine learning projects. And it sort of automates the groundwork of machine learning. And all of these generated notebooks and the generated code allow you to easily customize everything as well as meet compliance requirements. So for our example, we just took a small sample of the data set, and we then run an AutoML model. So if I go to my model repository here under the models tab, you'll see all of our models. And if I click on our AutoML model that we ran, I can then also enable serving, and serving will create a REST API endpoint that will wait for requests from your model. And this will allow you to serve your model in real time. So we've enabled all of this here, which, as I said, is literally the click of a button. And if we go back to our notebook, we then predict on a Spark data frame, and we then serve using that REST API endpoint. And over here, you can see our model predictions and our served model predictions compared to each other. So here's just a bit of more information on MLFlow that we can get to the end, maybe with some questions. And then onto learning machines. So Learning Machines has all of the expertise to help you implement Databricks as a solution. We have the qualified engineers who can help you do this. If you would like a private demo, you're welcome to give us a call and we'll do that for you. So thank you so much for attending the webinar. If you have any questions, now's the time to ask them.